Okay, so we are looking at synthetic division today, which I was just explaining only works when your divisor is pretty simple. It can't have more than two terms. It can't have a coefficient on the variable. It has to be something simple like r minus 9, x plus 2, and just because of the way that the shortcut works. First of all, we will start with the divisor. So we've got r minus 9 over here. We want to think about if r minus 9 were a root and divided evenly into this, then this would work. R minus 9 equals 0. So we want to figure out what r would have to be to make this divisor 0. So if r minus 9 equals 0, that means r would have to be positive 9. And so that positive 9, which is just the opposite of the number that's in here, goes in a little box like this. And then what we do is we take the coefficients from the polynomial that would normally go on the inside of your dividing symbol. And we just take the numbers, not the letters. So I'm going to have negative 9, 87, and negative 54. And you just kind of line them up like this. So here, here, and here. And you leave a blank space underneath. This is sort of upside down from the way we normally do long division. And you leave a space underneath and you put a long line down here. Okay? So far everybody understands where the numbers came from. It's super important that these are in order and that you don't leave any terms out. They've got to be in descending order, r squared, r, and then this would be r to the 0, which means it's gone. Okay, so we start by just bringing down negative 9. And then the process is a lot like long division. You're going to take 9 times negative 9.
Negative 81.
Negative 81, and we put that up here. And then you're going to add that to the 87. So basically it's 87 and negative 81.
6.
We get 6. And then you take this number times 9. So 9 times 6 is 54. And this last number you get over here, we box. That is the remainder. Okay, so this divided evenly. There's no remainder. And what you do with what's left is you start from the end. So this 6 would be a plus 6 on the end of the polynomial. And then you add variables as you go. So since we're working with r, we would get negative 9r for the next term. And they just go in order. If I had another number, I would have had r squared. But it didn't go that far. So on the end, you kind of put the r's back in. And so this is my answer. And I know it divided evenly with no remainder. It's a little weird, but once you get used to it, I actually prefer this, but like I said, it only works in some situations. So let's go over to number 2. A shortcut for figuring out the number that goes in the box is just to take the opposite of what's in here. If this is positive 1, we'll just put negative 1, because that's what you would need to make that 0. And then we'll take the coefficients out of here. So if I just have n squared, that's the same thing as 1n squared. We use 1. And then we'll do 8 and 7. I just space them out a little bit. Leave a space underneath, and then have a line where you can do your work. So we bring down the first number, which is just 1. And then this gets multiplied by your number out here. So negative 1 times 1 is negative 1. And that goes under the 8. And then you add the 8 and the negative 1 together. 7. And then 7 times negative 1. Is negative 7. And so this is my remainder. If it comes out 0, then you know that there's no fraction on the end of your polynomial. And we work backwards. The 7 becomes plus 7. What do I do with the 1?
It's just n plus.
It's just going to be an n. Or you can make it 1n if you prefer to have that 1 there. You can do that. Or you can just write n plus 7. So you work backwards because whatever the last number is before the remainder, that's your constant term. And then you just put variables on as you go. Okay, so the first two I wanted to have 0 remainders just to kind of get the idea. Now we're going to build a little bit from there. So if I have k minus 1, what goes in the box?
1.
Just 1, positive 1. And then we're going to take our coefficients off of here. So 9, negative 16, and negative 3. Leave a space. Make the line. So if we bring down the 9, then we'll have 9 times 1, which is 9. We're going to add that to the negative 16, which makes negative 7. Negative 7 times 1 is negative 7. And so this number right here is the remainder. So we'll talk about that here in a second. So if we just start with this part, I'm going to have 9k minus 7. And then the remainder works just like it did for polynomial long division. We're going to have minus 10 over what your divisor was, which is k minus 1. So that comes from up there. And you just tack that onto the end. But the nice thing in the middle, you can imagine if you have some really giant polynomials, you don't have to write quite as much. You don't have to write all the x's all the time. It's just kind of a nice little format. Okay, so let's do another one, and then things are going to start getting mixed up a little. So if I have m minus 8 here, I'm going to put positive 8 in the box. And out here we'll have 2, and negative 6, and negative 74. Leave a space, put the line. So we bring down the 2 just to start with, just to get this going. So 2 times 8 is 16. Put it over here. Add that to the negative 6. We get 10. 10 times 8 is 80. Add that to the negative 74, and we get 6. And they just box that off, I think, to help you remember that that's the remainder. So that 6 is going to become 6 over what your divisor was up here, m minus 8. And then, because this is positive, you put a little plus sign in front of it to separate from the rest of the polynomial here. So we'll have 10. And then this will be 2m, since we're dealing with m's. All right, so we did 2 with no remainders. We did 2 with remainders. Now we're going to look at some where they have mixed up the polynomials. So before we do anything, we want to put that first polynomial in order. Whether you're doing that mentally or on the paper, you have to think about what order this would be. So you want it to be descending order with the highest power first. So 7m squared plus 2m minus 8 is how we want to think about that. So that's what we're actually going to use when we put it into the little process here. So what goes in the box?
Negative 1.
Negative 1, very good. And then, except I forgot to put the 1, I put a negative sign. There we go, negative 1. And then we're going to have 7, 2, and negative 8. And just out of habit, I space these out because sometimes I get to going fast and not very neat. That just kind of helps me keep from squishing things together. All right, so talk me through this, guys. What would be the first step?
Bring down 7.
Bring down 7.
Bring down the 7, then what?
Then multiply by negative 1.
Multiply by negative 1, so negative 7, put it over here, negative 5.
1 is 5.
Good, so negative 5 times negative 1 is positive 5, and we get negative 3. You guys are fast. All right, so when we're rewriting it, what do I do with the negative 3?
It's your remainder, so it goes over m plus 1.
Okay, so it goes over m plus 1. And we just take that negative and put it out in front of the fraction, make that a minus sign. And this becomes minus 5, and this would be 7m. Okay, the next one has some bigger powers in it and a little bit of a twist.
We're missing r squared.
Yes, we are missing r squared. So we want to, I like to rewrite them first just because that helps my brain. So you start with the highest power, r to the 4th. You've got minus 7r to the 3rd, and there's no r squared. So you're going to have to put in a 0 r squared plus 4r minus 37. So I just rewrote this part, and it needs to go, the powers need to go 4, 3, 2, 1, none. Okay? So we have r minus 7, that means positive 7 goes in the box, and then we take these coefficients. So we'll have 1, negative 7, 0, 4, and negative 37. That 0 is going to play an important role here. All right, so we bring down the 1. 1 times 7 is 7, and we get 0, which is a little interesting. So 0 times 7 is 0. Add that, you get 0. 0 times 7 is 0. Plus 4 is 4. 4 times 7 is 28. Add that to negative 37, and we get negative 9. So my remainder is negative 9. So I'm going to have minus 9 over r minus 7. Then I have to really think to go backwards. So this 4 is going to be right there. This would have been r, this would have been r squared. So this 1 right here is r cubed. And then you're just going to put a plus sign in between them to separate. So you have to think about the powers. If you need to, think about, okay, this is r squared, and this is r cubed as you go back through. And so you might have some missing pieces in there, which is typically what's going to happen if there is a 0 in the middle somewhere. There was a 0 in here. There was missing stuff. Okay, so on the second page, the question that they're going to ask is a little different if we read the directions. It says, state if the given binomial is a factor of the given polynomial. Basically what they're asking you is, did it divide evenly? Or does it divide evenly? So how are we going to know if it divided evenly or not? If there's a remainder or not. So if the remainder is 0, we're going to say yes. And if the remainder equals anything else that's not 0, we'll say not 0. That might be a good way to put that in there. Then we're going to say no. Because basically it's just a matter of whether it divides evenly or not. All right, so you basically just do synthetic division like we did on the first page. So since I have plus 2 here, I'm going to put minus 2 in the little box. And I don't think there's anything missing. It looks like it's in order, so we can just do 2, 2, and negative 4. So bring down the 2. 2 times negative 2 is negative 4. Add that to 2, we get negative 2. Negative 2 and negative 2 makes 4. And we got a remainder of 0. So we don't have to turn this back into a polynomial. They just want us to know if it was a factor or not. So since this is a remainder of 0, that means it divided evenly. And we can say yes. If I wanted to get really technical, I could say yes, x plus 2 is a factor of 2x squared plus 2x minus 4. Or, for the sake of the homework, you can just show the work and say yes or no, but just realize that this would be a more complete answer. Okay? Moving on to number 8. We have plus 3 over here in the divisor, so we're going to use the opposite, which is minus 3. Nothing missing here, so we can just take the coefficients. So we have 1, 11, 14, and negative 22. So bring down the 1. 1 times negative 3 is negative 3. Add that, we get 8. Negative 3 times 8 is negative 24. Get negative 10. Negative 10 times negative 3 is 30. And we get a remainder of 8. So since we have a remainder that is not 0, we're going to say no, it is not a factor. And I don't have to do anything else with what's up there.
I gotta leave. Can I have the homework?
Yep. Okay, so let's look at the last couple. So on number 9, we have x plus 7 as the divisor, so we're going to use negative 7 here. So 9, 65, and 4 go here. Bring down the 9. 9 times 7 is negative 63. Add that to 65, we get 2. 2 times negative 7 is negative 14. Plus 4 is negative 10. So we can say no with an exclamation point. It was not a factor. On 10, I'm going to explain something else with this one we haven't talked about. So I have n minus 10. That means we're going to have positive 10 here. We'll use the coefficients, 8, negative 74, negative 61. So 8 is down here. 8 times 10 is 80. When you add those, you get 6. 6 times 10 is 60. And it was so close, but no remainder, so it's not a factor. Now, here's something else that is kind of cool. I want to show you something interesting with the one that worked. Let's go back to number 7. So we used negative 2. I want to show you what happens if I put negative 2 into this first polynomial. If I do 2 times negative 2 squared plus 2 times negative 2 minus 4, I get 0. Now, you're not excited. Let's go to the next one. If I put -3 into this big long polynomial, let me get where you can actually see it. So I'm going to put -3 into this first polynomial. So -3 to the third plus 11 times -3 squared plus 14 times -3 minus 22. I get 8. So this remainder is what you get if you put this number into the polynomial. We're going to use that in the next lesson.